Okay, so on Friday, we started getting into a problem that involved a circle, then the triangle, and the radius, and we had to do some work, right? We had to do some multiplying over and factoring out, things like that. So your problems today are going to be more complex also. So one of the problems in your assignment, I knew that you hadn't had an example. I wanted you to work at it. So we're going to do one now. So if you didn't get it done before, then you get to do what? Go back and do it. It is important that when you are drawing your pictures, you're making them large enough that you can write on them legibly. So you know what you're finding. I also do something like make sure I know I'm finding X is what I ultimately want to find. Okay? So it tells me, oh, I have two B's. One of them is not a B. But the bottom one is not a B. Okay, is it important that I label these correctly? Yeah. Okay, so it tells me from A to B is 32. It tells me that BAC is 38 and BDC is 54. How many triangles do you see in this picture? Three. How many right triangles do you see in this picture? Two. There is a small right triangle and a big right triangle. Can I use right triangle trig on this triangle? No, because it's not a right triangle. On your test, a couple of you tried to do that. It's not a right triangle, you can't do it. Okay, so since we only have two right triangles, we probably need to set some equations up for those things, correct? Yep. Okay, so I'm going to start. I always start on the small one just because my brain likes to, and my finger fits over the line really nicely. Okay, so I have 54. I'm ultimately wanting the what to 54? What part? Adjacent. And what is the part that both of those right triangles share? Not H, not the hypotenuse. Again, hard because they're putting an H there, right? Yeah. But they both share H. And in this case of the small one, that would be the opposite of 54, correct? Okay, so what function? Tangent. So I have tangent of 54 equals H over X. Now, we all know that if I have an equation with two variables, well, actually, this would be three because a theta would be a variable, right? If I had it. But I only have one known. I can't solve for one of these and have an exact answer, can I? No. So if you have two variables, you have to have how many equations? Two. So, well, we're lucky. Do we have another right triangle that involves both of those variables? Yes. So 38, and we have the opposite again, and we have information about the what? Adjacent. So the other right triangle is the whole triangle, correct? So opposite and adjacent, what function again? Shouldn't have written that close, sorry. So I have tangent of 38 degrees equals what? H over 32 plus X. So I have a system of equations, correct? Mm-hmm. We have methods to solve systems of equations. You have clear back to Algebra 1 when you use graphing. I don't want to graph that, do you? Nope. Okay, graphing, elimination or substitution. Those would work, right? We could use Gauss-Jordan elimination in matrices. You want to do that? No. So that leaves us down to elimination or substitution. Well, I think it'd be really hard to use elimination when you got fractions going on, correct? So we probably need to use what? Substitution. So we ultimately want x. So if we solve for h, if we solved both of these equations for h, then aren't they equal to each other? Because the transitive property, if one's equal to h, the other one's equal to h, they're equal to each other. Now, why am I solving for h? Because I want what? X. Because once I solve for h and put them equal to each other, there's no more h's. If I wanted h, I'd solve for what? X. See how I'm doing that? Okay, now if you have to solve for h and then plug it back in, that's fine. But if we can be efficient about it, we all know that us mathematicians are efficiently lazy, yes? Okay, so how would I solve this for h? Can't. Multiply both sides by x. The same thing you'd have to do if you were solving for x, correct? Because you've got to get the denominator out of there. So multiply both sides by x. So I get h equals x tangent of 54. So over here, how am I going to multiply by the quantity 32 plus x, right? So 32 plus x tangent of 38 equals h. Now I put the h's on the outside because now that they're both equal to h, we know they're equal to what? Each other. So once I've put them equal to each other, the h's are just irrelevant, correct? Transitive property. So what am I solving for? X. I'm solving for x. You need to keep reminding yourself of that because that means I need to get x's where I can manipulate them. Is the right of the left hand pretty good? Okay, what's wrong with the right hand? It has a quantity. So how do I get rid of a quantity? I need to FOIL, I need to distribute. Okay, so it's going to be 32 tangent of 38 plus x tangent of 38. Okay, in your brain, every step, what are you solving for? X. Basic algebra. What do you do in algebra? Keep it simple. I always tell myself, and people get so offended when I say it, keep it simple, stupid. It is a saying. I say it to myself. Do not get caught up. That looks huge, yes? But my basic algebra says I got to get rid of the quantity. I'm solving for x. So what do I now have to do?
Turn it into just
First I got to get all the x's where? On one side, right? So I'm going to subtract. I'm going to subtract this. So x tangent of 38. Now, can I do this math? No, you cannot do it. So I just have x tangent of 54 minus x tangent of 38 equals 32 tangent of 38. Now, if you look in the book, they might start working these things out. I don't ever do that. Because if you work them out, you have to carry around like 4 and 5 decimal places. What are the odds that you keep writing those 4 or 5 decimal places correctly? Not very good, are they? So just keep them. Okay, so now continue with basic algebra. I'm solving for what? X. My problem is I have how many x's? 2. I need how many? 1. Both of these terms have an x. So what can I do?
multiply them.
Well, you FOILed. Now you have to.
Divide.
What's the word for dividing when you have two things?
Multiply by reciprocal.
Factor.
Factor.
It's the other F word. Okay, they both have x's, so can I factor out an x?
Yes.
Yes. So x tangent of 54 minus tangent of 38. You will do enough of these problems that hopefully you get to the point where when you add or subtract this over, you just factor it out. Do you see it right there ready to factor out? What? Oh. But, I mean, can you see that ready to factor out here? Okay, so now that I have 1x, so I have x times this whole thing. So again, basic algebra, I have to divide it over. And I'm not writing it twice. So x equals, and I'm a weird one, I always write the denominator first. Tangent of 54, tangent of 38. Now, the denominator is a quantity, yes?
Yes.
Yes. I didn't write my parentheses, but if you were tempted to simplify the tangent of 38 and the tangent of 38, you better put them. Because we know with a quantity you cannot reduce unless you can reduce the whole thing or factor it out. I always say I'm going to hand out rubber bands for aversion therapy, so every time you try to do one of those basic algebra rules wrong, you just pull it back and snap it. It's called aversion therapy. Yeah, it doesn't sound like fun to me, does it? Okay, now do I have x? Okay, I don't know what it is, but do I have it?
Yeah.
Yeah. Okay, I'm going to see if they have any units on this thing. Oh, feet. So this is just feet. So what do I do now? Put it in my calculator. So then, I'm just going to use my phone today. Is that okay?
I guess so.
Okay. Now, the problem is, when you put this in your calculator, what do you have to put around your denominator? Parentheses, because of the quantity, yes? Now, put it in your calculator the way, put it in the calculator the way you would have before I said you have to put parentheses. Or here, you put parentheses, you do it the right way, I'll do it the wrong way. Okay, so tangent.
Look at you.
What mode do I need to make sure I'm in?
Degrees.
Degrees, how do you know?
They told us.
No. Because I'm in what? Degrees. If those were in radians, I need to be in what? Radians. Okay. You put parentheses in? I did not, did I?
No.
Okay, so these calculators follow order of operations, yes?
Mm-hmm.
So it would be grouping simples, exponents, multiply, divide, left to right, add, subtract, left to right, correct? So this calculator sees all of these are even because there's multiplication, division, subtraction, except for the subtraction. So it would go straight across. 32 times tangent of 38, we're doing good there, right? But then your calculator would only divide it by tangent of 54. What's it supposed to divide it by?
54 minus
Right.
38.
So you hit enter, I hit enter. What did you get? 42. I did not even get close, did I?
No.
Okay, so I didn't like my answer. You notice I didn't re-enter it. I hit second enter. Somebody told me the other day I could hit second and negative. Yeah, that doesn't, no.
Look what you did.
Yeah, it didn't do what I wanted. Okay, so I'm going to put a parenthesis there. And then I'm going to come back over here and put one right here. If I just hit a parenthesis right now, it's going to go over it. It's going to delete it. I don't want it to delete it. I want it to insert it. Okay, so look above delete. What's INS mean? Insert. So second, delete, insert, and now I can do it. And now do I get the 42.0?
Yes.
Okay, so is approximately 42.0 feet. Now, I'm going to tell you right now, you're not going to have a calculator all the time on the test. So what am I looking for?
This.
Okay, do you know why I don't give you a calculator on the test?
You
Anybody?
don't use it for dumb things.
So you don't use it for dumb things, and you could sit there forever because you're like, I know I'm not putting in my calculator right, and you're freaking out and melting down and not completing what you know, right? Okay, when it usually comes down to something silly like order of operations. Okay, now we're going to do the Ferris wheel problems, my favoriteest. Okay, we talked about this big, huge Ferris wheel the other day, didn't we?
Yeah.
Okay, I'm going to give you our visual again. This book is awesome because anytime there's a Ferris wheel problem, there's enough of them in the book, they put a Ferris wheel. So what that should do to you is say, okay, wait a second, how did we build this Ferris wheel? How did we do it? Because there's different parts of it and different things we'll do, but it's basically the same shape every time. Okay? So this is our cars. Look at that. Remember? Do you guys remember how many people were on that car? 40. How long did it take us to get around?
20 minutes.
Yeah, that's like scary. I don't know if I would love it that much, but I love Ferris wheels. Okay, so Mr. Ferris gave us this wonderful invention. So we are going to, very rudimentary, every time you see a Ferris wheel problem, you're just going to draw a circle, a center, those are just the things to keep it up off the ground, right? Mine are probably a little long. Does it matter? No. You're going to put, bless you. You're going to put a radius. They usually call this P of 0. That's position at 0 time. Is that where I get on this Ferris wheel at? Yep. And no matter where I'm going, I'm going to have another position. And they usually call it P sub 1. Position 1. And then we have our central angle. Now, are those guideposts, are these really important to us? No, not really. So a lot of times mine don't even have that. Mine just have, I'll show you. And you can decide which one you like better. I just draw an extra piece to the ground. Huh? It's like hangman. Okay, so I have an extra piece of the ground. Does that take out of that those crossbars? Yeah. So could you, when you have a picture in there, could you just make it that simple? Yep. Now we also have another piece. We have this piece right here that comes to the ground. So when I'm at P sub 0, I'm one position away from the ground, yes? And when so this would be like H sub 1. Can you see that green?
Yeah.
And this would be H sub what? 2. What other part are we missing? How about theta? Where does theta go? In the middle, right? So theta's right here. Now, that is supposed to be a theta, not a cube. Does that have to be realistic? Like, if my angle is 136, does this have to be 136? No, because it just needs pieces, doesn't it? Well, look what can happen here. What can I make?
A dotted line.
I made a right triangle. So by making a right triangle, could I find this height? Because I now have a rectangle, don't I? Yeah? I mean, there's some pieces here. I can make this a very basic shape. Every single time you're going to construct something like this. So maybe I should have made my circle a little bigger so I could write on it a little better, right?
Yeah.
Okay? So some things are going to tell us. We know that from the introduction, the diameter was 250 feet. So it's 250 feet. We know that 10 more minutes. So if the diameter is 250 feet, how much is the radius? 125. But look where I'm going to write it. 125 right there. Why? Because is that the radius too?
Yeah.
And is that part of my right triangle?
Yes.
Okay, so you're going to have some of these problems on your homework. And they're going to be where you have to set them up in pieces and fuse them together. Draw yourself a picture and we'll answer questions tomorrow, okay? Have a wonderful day.